Imagine a company that started out making graphics cards for video games, but ended up the center of the artificial intelligence revolution. That's NVIDIA. In 2025, NVIDIA briefly became the first company ever to hit $4 trillion in market cap, fueled by surging demand for its technology in AI. Yet many people still think of NVIDIA mainly as that graphics card maker for video games. In reality, NVIDIA has transformed into something much bigger, a backbone of modern computing. In this video, we'll break down what NVIDIA actually does in simple terms, from its products and its business model to the financials and future plans and the challenges that it faces. By the end, you'll see how NVIDIA went from powering video games to powering just about everything in today's technology landscape. At its heart, NVIDIA is a chip designer. It designs specialized microprocessors, notably GPUs, graphic processing units. GPUs were originally used to render video game graphics, but NVIDIA realized early on that their ability to perform many calculations in parallel made them ideal for other heavy computing tasks, especially artificial intelligence and scientific computing. This vision led NVIDIA to create a software platform called CUDA, like Barracuda, in 2006, which allowed developers to use GPUs for general-purpose computing. CUDA became a game changer, making it easier for researchers and companies to harness NVIDIA's chips for AI, data analytics, and much more. Over the years, this combination of powerful hardware and developer-friendly software ecosystem gave NVIDIA a huge head start. Today, if you're training a cutting-edge AI model or building a supercomputer, odds are you'll use NVIDIA's technology. So what does NVIDIA make? Well, its product lineup centers on high-performance chips and systems. Graphics cards or GPUs for consumers like GeForce series, which PC gamers use to play the latest games on high fidelity. These same GPUs are also used by artists, engineers, and cryptocurrency miners at times. Then there's data center GPUs for AI and servers, like the flagship NVIDIA H100 based on the Hopper architecture and the new Blackwell GPU series. These are the chips behind AI models like ChatGPT, and they perform massive number of calculations needed to train and run AI. Grace Hopper superchips, which combine NVIDIA-designed CPU, codenamed Grace, with a Hopper GPU in one package, enabling giant AI and high-performance computing applications. This CPU plus the GPU approach lets data flow faster between processor and graphics accelerator. Then you have DGX systems, which are essentially turnkey AI supercomputers. An AI DGX system packs multiple high-end GPUs plus networking into one server, so labs and companies can purchase a ready-made AI powerhouse. NVIDIA also offers DGX Cloud, partnering with cloud providers so customers can rent this hardware on demand over the internet. Networking and AI infrastructure. NVIDIA isn't just about chips on board. They acquired Mellanox in 2020, so they also sell ultra-fast network hardware that connects thousands of GPUs into clusters. Think of a supercomputer nervous system of such. Additionally, NVIDIA provides software frameworks for AI like NVIDIA AI Enterprise and simulation platforms like Omniverse for 3D collaboration and digital twins. NVIDIA's customer base reads like a who's who of the tech world. For example, OpenAI used thousands of NVIDIA's GPUs to train GPT-4. That's the model behind ChatGPT. Without NVIDIA's hardware, this AI boom that we're seeing right now probably wouldn't be possible at this scale. Microsoft has also invested heavily into NVIDIA's GPUs to power its Azure cloud and also partnership with OpenAI. In fact, Microsoft has deployed tens of thousands of NVIDIA's latest GPUs and is expected to ramp up that to hundreds of thousands over the years. Meta, or Facebook, whatever you want to call it, also uses NVIDIA chips in its data centers to train AI models like Llama and also powering its VR and AR ambitions. Even Tesla, which once relied on NVIDIA's automotive chips for its self-driving systems, uses NVIDIA's GPUs in its own AI infrastructure. Tesla has been buying NVIDIA GPUs to train its autopilot neural networks, even as it also develops custom chips of its own. And beyond those big names, virtually every cloud provider, like Amazon's AWS, Google Cloud, Oracle, etc., offer NVIDIA GPU computing as a service for their customers. In fact, data center operators like Microsoft, Amazon, and Meta made up nearly half of NVIDIA's data center revenues recently. When you hear about breakthroughs in AI, from self-driving cars to voice assistants, there's usually an NVIDIA processor crunching the numbers behind the scenes. NVIDIA's reach also extends to gaming consoles and consumer devices. The popular Nintendo Switch uses an NVIDIA chip, and the newly announced Nintendo Switch 2 is powered by NVIDIA's technology with AI upscaling for 4K graphics. This is a great example of how NVIDIA's innovations in AI cross over to the consumer experience, using AI techniques to improve game graphics in real time. Let's break down the revenue of NVIDIA. NVIDIA makes money by selling chips and systems across several segments, but one segment towers above the rest today: data centers. This includes AI chips, server GPUs, networking gear, and related software sold to cloud companies, enterprises, and even research labs. As of the latest financial reports, data center products account for roughly 88% of NVIDIA's revenue, an astonishing figure that shows how central AI has become to its business. To put that in perspective, in NVIDIA's fiscal year 2025, which ended I think in January of 2025, the company's total revenue was $130 billion, more than double the previous year. Out of that, roughly $115 billion came from the data center segment alone. That's a 142% jump in data center sales year over year. This explosive growth was driven by global demand for AI hardware. Companies worldwide were racing to buy NVIDIA GPUs to train advanced AI models and build new AI-driven services. The gaming division, which used to be NVIDIA's flagship, is still significant, but now much smaller relative to the data center. In fiscal year 2025, gaming brought in about $11 billion, roughly 9% of its revenue. In the most recent quarter, gaming chip sales rebounded as well. NVIDIA saw gaming revenue of $3.8 billion in the first quarter of fiscal year 2026. Up 42% year over year, thanks in part to new GPUs and console chips like those in the Switch 2. So gaming is healthy, but clearly overshadowed by the AI data center side. NVIDIA also has two smaller segments: professional visualization and automotive and robotics. Professional visualization contributed around $1.9 billion in fiscal year 2025, just over 1% of their revenue, supplying high-end GPUs for tasks like 3D modeling, animation, and virtual reality. Automotive and robotics was about $1.7 billion in fiscal year 2025. That's about 1% as well, covering sales of AI chips and systems for self-driving cars, driver assistance, and robotics applications. Not huge numbers yet, but these segments are growing fast. Automotive robotics revenue jumped 72% year on year in the latest quarter to $567 million, as more car makers and robot developers adopted NVIDIA's platforms. NVIDIA's chips are increasingly going into vehicles made by companies like Toyota and Hyundai, enabling advanced driver assistance and autonomous capabilities. In terms of profitability, NVIDIA, it's a beast. Its gross margins are high. It's over 70% in recent quarters, excluding one-time charges, and net profit margins have been around 50%. For example, in the quarter ending April 2025, NVIDIA earned $18.8 billion in net income on a $44 billion revenue, a testament to the premium pricing and enormous demand for its products. This profit surge and optimism about AI have made NVIDIA one of the most valuable companies in the world. As I mentioned earlier, its market cap hit roughly $4 trillion in mid-2025, putting it above tech giants like Apple and Microsoft at that time. Wall Street essentially views NVIDIA as the key player of the AI era, and so far the financials are backing that up. Now let's talk about how NVIDIA makes money. NVIDIA's business model is primarily about selling hardware and software ecosystems around it. It's often described as a fabless semiconductor company. NVIDIA designs the chips but outsources the actual manufacturing to those third-party chip manufacturers or fabrication sites. More on the risk of that later on in this video. The company then sells these chips in various forms. Discrete GPUs. These are individual chips or add-in cards like the GeForce cards sold to consumers, PC makers, or original equipment manufacturers, OEMs. Then there's server GPUs and systems. These are powerful GPUs like the H100 sold to cloud providers, enterprises, and also bundled into NVIDIA's own systems, DGX servers, automotive computers, etc. These carry a high price tag. A single high-end AI server with multiple H100s can cost hundreds of thousands of dollars. And then there's software and services. While hardware sales drive revenue, NVIDIA also monetizes software to an extent. It offers software stacks like NVIDIA AI Enterprise, which is a suite of AI tools and frameworks, on a license or subscription basis, and Omniverse for that 3D collaboration. In addition, NVIDIA launched AI as a service offerings in partnership with cloud companies. For example, DGX Cloud lets businesses rent AI supercomputing capabilities by the month instead of purchasing the hardware itself. These services and software help lock the customers into NVIDIA's platform and add incremental revenue. They also address smaller companies who need AI power but can't afford to buy entire clusters of GPUs outright. And then there's the automotive platform. NVIDIA sells its Drive platform, which is computing hardware and software, to automakers. This often involves long-term deals where NVIDIA chips and AI software will be integrated into future vehicles, and the automaker pays per vehicle or per project. For instance, NVIDIA's Drive Orin or Drive Thor chips aim to be the brains of autonomous driving systems in cars launching in just the next few years. A key element of NVIDIA's strategy is that it's not just pushing chips, but a full-stack platform. And by providing CUDA software, the libraries and development kits for everything from robotics to healthcare to graphics, NVIDIA ensures that developers write their code to run best on NVIDIA hardware. This ecosystem creates somewhat of a moat. Even if a competitor were to make a similar chip, they'd also need to convince developers to switch their ecosystems. As a result, NVIDIA enjoys a dominant position. For example, most popular AI frameworks are optimized for CUDA, their software, and NVIDIA's GPUs by default. This is a big reason why NVIDIA has maintained an edge over rivals in the AI chip space. So where is NVIDIA heading next? Well, the company is signaling that it wants to ride the AI wave as far as possible, not just by selling more chips, but by moving into services and new markets powered by those chips. One major direction is offering AI infrastructure as a service, often in partnership with cloud providers. Jensen Huang, the NVIDIA's CEO, has described the idea of NVIDIA becoming an AI utility, comparing AI computing to a new form of critical infrastructure similar to that of the electricity or the internet. NVIDIA is building out their NVIDIA DGX Cloud on platforms like AWS and Microsoft's Azure, so customers can basically rent out a virtual AI supercomputer by the hour. This caters to companies that need access to powerful GPUs for AI workloads, but don't want to manage physical hardware. NVIDIA also launched cloud services for custom AI model development. For example, its AI Foundations model for text, image, and biology allow enterprises to adapt large pre-trained models using NVIDIA's own cloud-hosted GPUs. These AI as a service moves could open up new recurring revenue streams and make NVIDIA less cyclical. Robotics is another frontier. NVIDIA is positioning itself to provide the computing brains of robots and autonomous machines. They have a platform called Isaac for robotics developers and recently even announced Isaac AME, a generative AI model for humanoid robots to help robots learn and move more intelligently. NVIDIA's hardware is used in warehouse robots, drones, and industrial automation. Basically, as robotics advances, each smart robot could contain NVIDIA chips for vision and AI. The company's push into simulation also supports robotics and automation development, since you can train robots in realistic virtual environments before deploying them in the real world, and hopefully avoiding Terminator. In the automotive industry, NVIDIA's future goal is to be a central computing platform for next-gen cars. Modern electric and autonomous vehicles are essentially computers on wheels, and NVIDIA is developing supercomputer-level chips like NVIDIA Drive Thor to handle everything in the car: self-driving AI, camera processing, infotainment, and more on one unified platform. Major car makers like Mercedes-Benz, Volvo, Jaguar, Land Rover, Hyundai, Toyota have partnered with NVIDIA to use its Drive chips and software in upcoming models. While automotive is still a small slice of revenue today, the potential is huge. Think millions of cars, each eventually needing hundreds or thousands of dollars worth of chips. NVIDIA is planting seeds here that could pay off as autonomous driving becomes more mainstream. We also see NVIDIA expanding into designing CPUs or central processors with its Grace CPU. This is significant. Traditionally, NVIDIA only made GPUs or the graphics processors and left the CPU to the likes of Intel or AMD. But with Grace, an ARM-based data center CPU, the combined Grace Hopper superchip, NVIDIA is saying it wants to provide more of that computing stack, especially for AI and high-performance computing needs. This could pit NVIDIA in a closer competition with those CPU makers down the road, but also could increase its share of each system's components. Furthermore, NVIDIA continues to refine its GPU architectures. After Hopper and the current Blackwell generation, there will be more. Each generation tends to increase performance dramatically, which will enable even more sophisticated AI models and simulations. In short, NVIDIA's future is about extending its dominance in AI, making sure that AI moves into new domains from the cloud to the edge devices to vehicles and robots. NVIDIA's chips and software are what everyone uses. The company is also likely to keep growing its services and software offerings, which could smooth out the hardware sales cycles and deepen those relationships with customers. NVIDIA's story sounds almost unstoppable, and there are real risks and competition that could threaten its position. Here are some challenges that they're going to face. Competition from other chip makers like AMD, Google, etc. NVIDIA's success has drawn many challengers. AMD, its longtime rival in graphics, is aggressively moving into AI accelerators. For instance, AMD's new MI300 series GPUs, they boast huge memory and aim to rival NVIDIA's H100 in performance. AMD and others often price their chips lower than NVIDIA, hoping to undercut that leader. Then there's Google, which designs its own chips for AI. Google's TPUs power many of Google's AI services and are offered on the Google Cloud, meaning Google isn't buying as many NVIDIA chips for those tasks. Amazon has developed custom AI chips for its cloud services as well. If these in-house solutions by those big players get more capable, they could reduce demand for NVIDIA's products from some of the largest customers. Startups are also in the mix. Various firms like Graphcore or Cerebras have built specialized AI chips. While none have seriously dented NVIDIA's dominance yet, the landscape is crowded with innovators, and in 2025, NVIDIA still enjoys a big lead due to its software ecosystem, that CUDA, and the sheer performance of those GPUs that they make. But the gap may narrow. Any sign that a rival chip performs significantly better or is much cheaper could pressure NVIDIA's growth or pricing power. Then there's reliance on TSMC and the chip supply chain. NVIDIA designs world-class chips, but it does not manufacture them. It relies mainly on TSMC, or Taiwan Semiconductor, the world's leading chip manufacturer, to produce the latest GPUs on advanced silicon processes. This exposes NVIDIA to supply chain risks. If TSMC faces capacity issues or geopolitical tensions threaten Taiwan, where TSMC is based, NVIDIA could struggle to get its products made. There's also a dependency on cutting-edge manufacturing technology. Only TSMC can make chips as advanced as NVIDIA needs. For instance, NVIDIA's H100 is made on a 5 nanometer process. Its future chips will use even smaller, more advanced nodes. Any delay or disruption in those processes, say due to export restrictions on chip-making equipment or global crisis, can hurt NVIDIA's product timelines. This reliance on external fabs means NVIDIA doesn't fully control its destiny on the production side. The company has started multi-sourcing some components and could explore partnerships to mitigate this risk, but the TSMC factor remains a significant risk hanging over NVIDIA and the semiconductor industry at large. Now let's look at geopolitical and regulatory risks. Being at the top of the AI hardware field has drawn government attention. The US government, citing national security, has imposed export restrictions on NVIDIA's high-end chips to regions like China. In fact, in early 2025, the US abruptly required NVIDIA to stop selling certain AI chips, a specialized H100 variant called the H20, to China, which forced NVIDIA to take a $4.5 billion inventory write-down and forego an estimated $2.5 billion in additional sales. CEO Jensen Huang noted that Chinese AI chip market, worth potentially $50 billion, is now effectively off limits due to US export controls. These restrictions could tighten even further, or other countries might impose their own rules. On another front, as NVIDIA grows, there's the question of antitrust or competition law. Could regulators eventually scrutinize NVIDIA's dominance in AI chips or block certain acquisitions? It hasn't been a major issue yet, but it's something to watch as NVIDIA's influence in tech rivals that of the biggest tech firms. Another risk is customer concentration in AI demand cycles. NVIDIA's boom is tied to an AI surge. If, for example, big customers like the cloud giants reduce spending on AI, perhaps they overbought on capacity or macroeconomic factors cause budget cuts, NVIDIA could feel a dip. Right now, companies are racing to add AI, but eventually this could moderate. There is news that major customers like Amazon, Microsoft, and Alphabet or Google have faced investor pressure to rein in heavy AI spending. If those customers temporarily pause orders to digest what they've bought, NVIDIA's growth might fluctuate. Moreover, a few customers account for a large portion of revenue. For instance, just a handful of tech giants made up almost half of the data center sales. Losing one big account or a delay in orders could impact quarterly results. Then there's emerging technologies and alternatives. Longer term, the landscape of computing can always shift. AI itself might see new types of hardware. For example, quantum computing or optical computing in the far future that could diminish the need for GPUs if that pans out. While such technology is not replacing GPUs anytime soon, NVIDIA has to keep innovating to ensure its GPUs remain the go-to solution. The company is aware of this and has stayed at the bleeding edge. It even opened a research center on quantum computing integration. But the risk remains that a paradigm shift in computing could catch any incumbent off guard. In summary, NVIDIA's dominance isn't guaranteed forever. It must navigate competitive pressure from the likes of AMD and in-house silicon at big tech firms, manage geopolitical constraints, and continue to justify its hype. The good news for NVIDIA is that they have a multi-year lead, a deep ecosystem, and enormous demand and tailwinds. But the next chapters will be about execution and adaptation in a fast-evolving market. NVIDIA has evolved from a niche graphics card supplier into the engine of the AI era. Its hardware and software power not only breathtaking video game graphics, but also the AI models that are transforming industries. From how your social media feed is curated, to how doctors analyze medical images, to how cars can drive themselves. The company's bet on GPUs for general computing and its cultivation of a whole developer ecosystem, the CUDA and beyond, turned out to be incredibly prescient. This has led to staggering growth, both in technology impact and market value, making NVIDIA one of the most valuable and strategically important tech companies in the world. However, as we discussed, NVIDIA's story is still being written. It is now sitting at the top of the mountain that others are eager to climb up. The company's future will hinge on how well it can maintain its lead in AI hardware, diversify into new services, and navigate the external challenges from competition and geopolitics. Will NVIDIA continue to dominate the next decade of computing as AI workloads explode further? Given its track record of innovation, the odds look favorable, but nothing's guaranteed in tech. What's clear is right now, NVIDIA is doing more than just making graphics cards. It's building platforms that underpin modern AI and advanced computing. And whether you're chatting with an AI online, playing the latest video game, or one day riding a self-driving car, there's a good chance NVIDIA is working behind the scenes. In short, NVIDIA makes the brains that are powering the computers of today and the intelligent machines of tomorrow. And that's what NVIDIA actually does, in a nutshell. If you found this explanation useful, give it a like, maybe hit that subscribe button for more deep dives into other companies. And YouTube thinks that you'll love watching one of these two videos next. Until next time, have a great day. Thanks for watching.